It is going to be start. So today we are going to discuss about a new chapter, which is the part one actually uh, related to the cryptography. That's great. So today we are going to discuss about the cryptography part one. When we're discussing about the cryptography, so it means that today we are supposed to discuss about the few of the terminologies which are related or linked with the cryptography, as well as to understand them. And then we need to understand what is the cryptography, its classifications, are its main types, are its main groups. And then we will discuss at least one of them by our today's lecture. And the second type or the second group, we will discuss it in our next lecture. So, first of all, we need to understand that what is actually cryptography. The cryptography, actually, it is a Greek word, and it is actually in Greek, we write as a crypto, which has a meaning like hidden, something which is not open. So in Greek, we call crypto, which means hidden. And graphene, it means to write. So when we combine them, it means write in a hidden format, or hidden written, or hidden writing, or something which is not means openly available. This is actually the meaning of the cryptography. So it means in cryptography, we are trying to write something in a hidden format, even if it is available, accessible to anyone. They can see, they can read, but they cannot understand what it is. So the cryptography is derived from the Greek word crypto and graphene. Crypto means hidden and graphene means to write. Now cryptography is a process, complete process, which provide us the security information. Mainly the concept or the logic, what we understand from the cryptography is actually to provide the secrecy or privacy or security for the data, but the data while we are communicating. In other words, we can say that this is the something which is applied for secure communication. If we just go back, we said that the cryptography is from a Greek word. It means hidden, to write, or something write in a hidden format. So it means that cryptography actually provide us the source while we are communicating with each other, the data packets, what we discussed already earlier, from Alice to Bob, while the data packets are traveling from one point to other point, so we need to hide them. Here the hide doesn't mean that someone cannot see. Here the hide, it means that we need to change the form that even if suppose someone can see but cannot understand. That is known as in hidden format. But the main point is that this practice is for the communication, for the secure communication only. So this is giving us a very clear message that the cryptography is actually the something which is actually during the means data packets when they are communicating data packets from source to the destination. Secure communication. We use this for secure communications between maybe individuals, maybe governments, maybe agencies, maybe military, maybe anyone, maybe between us, maybe between you, maybe between among your family, any place. But the main thing is that it is about the secure communication. Cryptography is also used for protecting data at rest. So that's what we already discussed. Now, when we protect the data, it means we change the format in a hidden format. Here we cannot say hidden format, but we will see in a secret format. So when the text, say for example, we have hello or hi. So hi is known as a plain text. When we wish to apply the encryption on that, so for example, we are replacing H with the hash sign and I with the @ sign. So it means now we will replace it hash @ it means it is encrypted text, and that text will be known as the ciphertext. And once when this ciphertext reach to the destination, we can decrypt it. Decrypt it means that we wish to bring it back into the real position. So while we're going for bringing it back to the real position, so the hash and @ sign will again reconvert it into the high. This is the phenomenon for the encryption or the process what is normally adopted for the cryptography. So I hope that you understand. And from this, you understand also that actually what is the mean by the cryptography and encryption and the ciphertext, and what is the meaning by the plain text as well. Now, if we just go ahead, we need to understand a bit more that actually people who study and develop the cryptography algorithms are called the cryptographers. These are the terminologies we are trying to understand. Like we are saying, we have the cryptography, we have the encryption techniques, we have the encryption algorithms, AES, DES, SH, so many different, symmetric, asymmetric, so many. So those people who are developing this cryptographic algorithm, they will be known as cryptographers. If you are writing any algorithm, then you will be known as the cryptographer as well. Now, the study of how to bypass the use of the cryptography. The one who is writing the encryptions is known as the cryptographer. The study of how to bypass the use of the cryptography for the unintended recipients is called the cryptanalysis or the code breaking. So the group of people, the one who is there for the code breaking, or the one who is there for the bypass the cryptography encryptions, that one will be known as the cryptanalysis. Cryptography and cryptanalysis are both together. One thing is writing the encryptions and cryptography techniques, and the other thing is to bypass it or to break it. They both are grouped together under the one umbrella, and then we call them, this is the cryptology. Going to define you to make you simple for you. Number one, those people who are writing the codes, writing the encryption techniques, they are known as cryptographer. Those people who are bypassing this, they are known cryptanalysis. And the cryptography and cryptanalysis, when we join together under the one umbrella, we call them cryptology. And what's the cryptography? Is actually taken from a Greek words, which is the crypto and graphes. Crypto means hidden and graphene means to write. To write something which is in a hidden format. Hidden format means in a secret format. Here the meaning of hidden is not something that someone cannot see it, but it is in a hidden in a means that it is in a secret format. So these are the terminologies you have to understand, very important, because later on we will discuss these things. So you need to know what is the crypt, what is the cryptography, what is the means cryptograph, and what is the graphene, what is the plain text, what is the ciphertext, what is the crypto analysis, what is the cryptology. These things are very simple. You need to understand only once. Going ahead. Now the question is why we need the cryptography. We need the cryptography because when we are sending the data packets, see from this figure, Bob is sending a packet to the Alice. What happened? While the time of communication in between, which is the cloud, you can see that's the channel, internet. Maybe the Darth is there and the Darth is trying to read or get the data packets. In this mode, it's not doing anything. So that's why we call that this is the passive attack, because he's just only trying to get the information. In the second phase, which is the active attack, now the Darth is trying to retrieve the messages of Bob, as well as trying to make the changes in it before passing it to the Alice. So this is the means active attack pattern. Now why we need the cryptography? Question is still there. We need the cryptography to keep this Mr. Darth out from our communication. To make it sure the Darth is there, but Darth is not able to play with our data packets. Not in a passive format, not in an active format. This is the goal of the cryptography. So I hope you understand why we need the cryptography. A few more terminologies. When information is transformed from a useful form of understanding to an opaque form of understanding, this is called encryption. The same thing, the same concept, that's what we discussed previously and also a couple of minutes before. When information is retrieved back into the useful form, it is called decryption. So here he is trying to explain you what is the encryption and what is the decryption. Now, intent and the recipients are authorized use of information is determined by whether the user has the certain piece of secret knowledge. The only user which has the required certain amount of the knowledge can transform the opaque information back into the useful information. The secret knowledge is commonly called as a key. Not to be worried in the terminology what it is written. Simple. It's saying what's the encryption. It's saying that when we have some text information, we try to convert from its useful understanding to the opaque. This will be known as encryption. Not to be worried, make it simple. When we have a plain text, we convert it into the ciphertext. That is the encryption. No need to be got confused with these terminologies. And when we have a ciphertext, we bring it back to the original text. That is the decryption. And how we'll convert the text from encryption, from the plain text to the ciphertext, and from ciphertext back to the plain text. We can do this using some authority, some mechanism, and that thing is used, or that thing is known as the key. And the key will be to anyone who is authorized for that. I hope you understand. Not to be worried about the text and the terminologies. Moving ahead. Now, the key will be generated by using algorithm. So key is there, but each algorithm, each encryption is responsible to generate a key. Rather a one key, rather a two key. We're not going into detail for one key or two key at this moment, but later you will understand why we said that one key or two key. That will define the type of the class of the algorithms, encryption techniques. But at the moment you can say the key only. The key will be generated by each of the algorithm. For what? To perform the encryption and decryption. Encryption, it means to change the plain text to ciphertext, and decryption means to change the ciphertext back to the plain text. Now each algorithm will perform the key. This is a very meaningful message. It means if suppose we have 10 different algorithms, that means they will generate the 10 different keys, and those keys will be different from each other. The information in its useful form is called the plain text. Now is coming back to the same thing, that's what we already discussed, or clear text. And it is encrypted form, it is called the ciphertext. So the same thing, that's what we discussed already. Now, another terminology, another concept is known as the secret key. Secret key is used in the symmetric cryptography for encryption and decryption. Very important. The key is always required. We need a key always for encryption and decryption. And the key which is being used for encryption and decryption is known as a secret key. In which type? In symmetric cryptography type. It's important. You need to understand. Okay. What it means, we call as with a common name, which is known as a secret key in symmetric approach. The same key will be used for encryption and for decryption. This is a message that we are using only one key, no more than one key. But now under the symmetric, group of symmetric, what algorithm we are using, each algorithm will have his own key that will be different from the other. But the thing is, we are using only one key. And you know, this comes under the class of symmetric. Symmetric, symmetric. I repeat it 3 times. The reason I repeat it 3 times, because this symmetric, it means the same key we are using. That's why we call this as symmetric. So this is known as the symmetric key. Now, asymmetric. In asymmetric, we actually use the 2 keys. One is known as the private key, and second is known as the public key. So when any algorithm is using the 2 key format, one for encryption and other for decryption, or either the combination for encryption or the combination for decryption, that comes under the asymmetric type. So the private key is a concept is used in asymmetric cryptography for decryption. Going back what I explained to you right now, the secret key we are using in symmetric. So whenever you find this terminology, a private key, so you can, without thinking, you can say that this encryption technique or algorithm, whenever we're saying encryption technique or algorithm, this is pointing to the same thing, not to be confused. This comes under the class of asymmetric, because in symmetric, that will be only one key, must be one key for both purposes, for encryption and decryption. We need 2 keys for encryption and decryption process whole, like private and public key. That is in a symmetric approach. This is the very bottom line, clear difference among both of them. Going ahead. Now, public key, what's the difference between the public key and the private key? This is as well important to understand. So going back, see where we discussed about the Bob and Alice. One key is private key. The private key will be the key for Bob and will be the key for Alice. The public key will be the key which will be shared by the Bob and by the Alice as well. So what could be the best example for this one? How you can understand? You can understand, I hope that you know about the locker system in the banking. If you know about that, you can understand this private and public key concept very simply. For example, while we are going for the bank, we have a locker, we open a locker, bank issues us the one key, and the one key, which is known as a master key in that case, is always with the bank manager. Now, when we want to go to open or access our locker, we have our key, but we cannot access our locker. We need the key of the manager as well to open it. Now, when we use our locker, we just close it down, shut it down, keep it safe. Now, at this stage, even the one of the key is with the bank manager, and even he is the manager, but he will not be able to open the locker without our key. So locker needs a combination of both of the keys to open, otherwise cannot. So the key which is with the manager, that's the public key. That key will be used for all of the lockers. If suppose the bank have the 100 lockers, that will be public, that will be common. Public means common. That will be common for all of the 100 lockers. But your key, which is for locker number 7, will be only used for locker number 7. This is the private key for you. So I hope that you understand the core concept about that, what it is. Going ahead, I hope you understand the primary and this key, because these are the very important concepts and the base for the encryption to understand. Okay. Now, the common goals, the other things, that is, what is the data confidentiality, data integrity, what it is, why we are discussing these things now. Actually, we have 4 main goals for our cryptography. So, what are those 4 goals? Among them, number 1 is the data confidentiality, data integrity. So you know what's the data confidentiality? That only an authorized person should be able to get the information. Like in the banking system, locker example, only the authorized person who is authorized for the locker number 7, who has the key, private key with him, that person can only be able to access the locker. Data integrity, that the person who is receiving the contents of the message must be sure that actually the data what is he or she is receiving is not altered, no alteration in it, no editing in it, no changing in it, but that is in a safe and sound mode. The same CIA, this is the same CIA concept. So authentication, the recipient should be able to verify from the message that the identity of the sender, the origin and path, or all of the combination are verified. They are not coming from unknown sources. They can be validated. Number 4, non-repudiation. The emitter should not be able to deny for sending the message. So this CIA and non-repudiation, these concepts we already discussed in our previous classes. So these are the 4 goals for our cryptography while we are applying the cryptography. To achieve these 4 goals, I hope you understand that what. Now, when we come to the classification of the cryptography, as we discussed a couple of minutes before, that something is symmetric and asymmetric. So this cryptography is further divided into the 2 classes, 2 types, whatever you feel comfortable you can say about that. One is symmetric, other one is the asymmetric. Now you can see the symmetric further divided into DES and AES. So this is actually the symmetric is not only the DES and AES. These are the only 2 for your understanding. We have many algorithms. In asymmetric, same according to asymmetric, DSA and RSA. But we just choose a few just to give you, and you can see from the arrow that these are the more algorithms which can come under the symmetric or asymmetric, and also the new algorithms, they can come under this. So what is the difference between them? Because those algorithms which comes under symmetric, it means they will be using the 1 key. Those which are coming under the asymmetric, it means they will be using 2 keys for the encryption and decryption. This is the main difference and main classification. Going ahead, going to explain you further about this. Symmetric cryptography, we already discussed, now we're just going to recap this one. A cryptography approach in which the sender and receiver of a message share a single key. That's what the major difference between the symmetric and asymmetric, that's what we discussed already. So they share a single common key that is used to encrypt and decrypt the message. Means for encryption, and for decryption, for both operations, it can be used only the one single key. In other terms, data is encrypted and decrypted using the same key. And that same key is known as what? You remember the name for that? That we call that it is the key which is known as secret key. Refer to slide number 6. So secret key, or whenever you find a name for the key is secret key, this is also a very loud message that this means the algorithm which you are using that is actually belongs to the symmetric approach. When you have the private and public key, so it means that a very loud message that this is the asymmetric approach actually. In fact, symmetric key cryptography is sometimes called secret key cryptography as well. Why we call secret key cryptography? The reason is that because it is using one key and that key is known as a secret key as a common name for this type of the cryptography. So we call that as the secret cryptography. How it's working? You remember we discussed that it goes from the plain text to ciphertext and then from ciphertext to plain text. And then it is using the same common key. So you can see from here that in this case, actually, that this is actually the plain text. Then we apply the encryption. Then this is actually the hidden text as per the crypto and graphene, the Greek word. But this hidden, it means that it is encoded text. Then we apply decryption here, and again we form the plain text here. So this text and this text is the same. We just changed its condition while it was in between for the communication there. So we did that using the key. We use this key to encrypt. We use this key to decrypt from cipher to the plain text. But this key and this key, these both keys are the same. That's why we are saying as a symmetric key. So you can see the same key is applied here and the same key is applied here. So you remember, if we apply the same key, so we call that as a secret key. So this is the secret key. And this comes for the symmetric cryptography. So it's very simple, totally simple. Now in the we further try to elaborate this example. So you can see from here, this is the sender, means this is the Bob, this is the recipient, this is the Alice. So now plain text, we apply this encryption, then it is converted into ciphertext, then we apply decryption, then again it will become the plain text and it reaches to the Alice here. So for this operation and for this operation, for both of the operation, we are using this key, which is the shared key, common key. So that's why this is the known as the symmetric approach. So now you can see Mr. Dart, what it was in our active attack and passive attack was there. So Mr. Dart was here. So no need for Mr. Dart. We omit him by using this approach. So this is the whole phenomena. We can also see that how we are applying from plain text, we encrypt, apply the key, and then it's converted to the ciphertext also, and we apply the key. So how we can convert from here to here and convert from here to here. The both operations are shown in the flow diagram as well for your more better understanding. I hope that you understand. It's very simple. Now we're just giving a bit touch about asymmetric so you can differentiate between the symmetric and asymmetric. You remember when we started this lecture, we said that this is the cryptography part 1. So the cryptography part 2 is actually about the asymmetric. So in the next lecture, we will discuss about the asymmetric part. So now in asymmetric is actually cryptography algorithms uses always two keys as we discussed. One is the private and the other one is the public key. How they are using? In what pair they are using, we will discuss in a more detail in our next lecture. So you can see from here, one to encrypt the data and another to decrypt the data. These keys are generated together. This is the most important point. And you remember in symmetric also, we said the keys are generated by the algorithm themselves. We are not taking from outside. They are generated by the algorithms. Your next lab, which is I believe tomorrow, we will go with the one of the symmetric approach. Maybe probably it is the SH1 or something. So then now the time's there, I will explain you that how it is working. So you will be able to understand that how these things are working, because we were waiting for this lecture so you can understand the core concepts, so you can understand it how it's working. So the tomorrow lab will contain more actually about the explanation before you will be going to adopt that one. So one is named as the public key and other one is named as the private key. That's what we discussed in a couple of minutes before. Both sender and the recipient has to share the public key. Remember the same example, what we discussed about the banking. So this is the same example that will be applied here as well. How they are doing this whole operation, we will discuss it in our next class. Well, we will be discussing in detail about the asymmetric cryptography. So just for your understanding, so just see here that in asymmetric cryptography, how it is happening, the process is the same. We have the means plain text, we try to convert it to ciphertext, and then we again convert to the plain text. The same thing. But we are using the two keys. Now to means from plain text, so how we are means converting to the ciphertext, we are applying a public key and a private key. So this is the Bob's private key. So we are applying the two keys actually to convert into the ciphertext. When we are reaching here, so we are using the private key of this gentleman, this lady, Aries, and we are using the public key. So you can see the public key is common, like the one of the example what we discussed about the banking. Here, this private key belongs to this person, and this private key belongs to this person. This is how we are using this one. This is, we are trying to make it more secure. But there are other issues as well. Like if suppose we are making more secure, then it means that it will be required more computation power as well. So these things we will discuss later. Now in asymmetric, you can see here, if I just go back here, this is the same. You can see the one key is pointing here and here. But in this process, you can see that there are the two keys separately. This is the means public key and this is the private key. The rest of the operation is the same. So the further we will again discuss in our next lecture. One more example, how this is working. This is in steps from the flow. So how it is going to be done, and finally how it is going to be converted. So where what applying the keys. So this is a public key, so it is shared among both of them. This is the private key. Again, this is the public key and this is the private key. So here we are encrypting, here we are decrypting. I believe this is very simple. You understand the things simply. Now, here we need to understand, to have a little bit comparison between the symmetric and asymmetric. In asymmetric ciphers, no secret channel is required. What do you mean? Like suppose while we are communicating here, let's go back. This channel, no dedicated cipher channel is required in asymmetric. But in symmetric, we require the dedicated cipher channel. That's what he is explaining to us here. So in asymmetric cipher, no secret channel is required for the exchange of the public key. The receiver needs only to be assured the authenticity of public key. That's it. In symmetric ciphers, requires a secret channel to send the secret key generated at the one side. Because in symmetric, we generate only one key. That key is generated only on the one side, which is the side of the bob. And then we send the data, and also we send the same key to the Alice as well. So that's why we need to have the secret channel also. But in asymmetric, one key means generated private key on Bob side and other one is on the Alice side. So only we need to share the public key. So that's why we don't need any secure or dedicated channel between that. So from this example, you can understand the asymmetric is more powerful. But the thing is that asymmetric means requires more resources as well, more computation power as well, more energy as well, and it will require more time as well. So in most of the wired environment, we are using asymmetric. But in wireless, we are using both. But for few of the applications, we have limitations. For these resources, we cannot use the asymmetric. For example, just only for your understanding, in Internet of Things, they're very small. So sometimes we are bound that we need to use only the symmetric approach. Anyhow, we will discuss further later in more detail. Now, asymmetric algorithms used for the large size of the keys. The key has the size, like such as 1024, 2048 bits, where the symmetric use is very small, like 56, 128, 256 bit. So you can understand that they are very lighter. Symmetric is very lighter, specifically more applicable for wireless networks. And asymmetric means having a large keys. Comparatively, that's more secure as well. But what means by the bit of this much number of bit of the keys? What it mean actually? So this you will learn in your lab class. Will explain you one of the algorithm. So you will see that how the iterations are taking, what is the key, what's the header, and how means it is going to be encrypted and how it's going to be decrypted. We'll try to explain the whole process. So it will be very, very important. So please don't miss anyone the lecture for tomorrow. So you will understand it how these keys are working. Asymmetric ciphers tend to be about slower. So this will be slower. Why it's slower? Because it is having a large key, using the two keys, it needs more computation. So for that, it will need more power and more time as well. So that's why it will be a bit slower. While asymmetric, it is lighter and faster. But when we talk about security, for sure, asymmetric is more secure compared to the symmetric. Then why we have symmetric? Why we don't have the asymmetric for everything? We cannot, because it varies on application to application. Some of the applications asymmetric doesn't suit, and some of the applications symmetric doesn't suit. So you will learn with time. Going ahead, symmetric versus asymmetric cryptography. In asymmetric algorithms means they generate the complex, secure, and large ciphers which are almost unbreakable. We cannot say they are. Everything is breakable, even with the modern computing power, but they take more time in encryption and decryption as compared to the symmetric. Why they are taking more time? That's what we just discussed a couple of minutes before. Symmetric ciphers, they can be cracked through a brute force attack. I hope that you know what's the brute force attack, in which all possible keys are attempted until the right key is found. The brute force is a mechanism, is an algorithm, which is actually there to break the enemy's keys. So it can go for the maximum possible combinations, like suppose 256 bit or whatever it is. So how many maximum possible options will be there, and then it can break it. So because the keys are short, So there are the possibility that they can be break using this brute force. But in asymmetric, the chances are very, very low, but we cannot say 100% no. This is not possible. So keep in mind. Usually asymmetric encryption takes relatively more time. So you know now why it's taking more time. Most real systems uses even a hybrid of these two encryption methods. Depend on system, depend on application, what system we are using. If we need even more higher security, we can go for the something which is known as the hybrid. Hybrid one means it means that we are using the two of them together. Secret key used in the symmetric encryption is encrypted using the asymmetric encryption. This could be possible as well. To be sent over an insecure channel. You remember we said that in secret key, which belongs to the symmetric approach, and the key is generated at the one side from the Bob side, and then we need a dedicated channel, encrypted channel, to send it to the Alice. And now what he's saying, that secret key we create and then we apply the approach, asymmetric approach on that, asymmetric encryption on that particular key only to secure that key in case that we can avoid the encryption channel. This could be the possibility as well. To send over the insecure channel, while the rest of the data is encrypted using the symmetric operation. So we do the symmetric operation, it's not a problem. This approach is also known as the hybrid approach. Because hybrid approach, it means that where we are using means the combination of the more than one. How combination we are making, this means totally depend on us, not an issue. When the receiver gets the asymmetric encrypted key, he uses his private key to decrypt it. So in this whole phenomena, we are using the asymmetric not on the data packets, but we are only using that on these, means secret key, symmetric key only, to keep the key safe. And then we are doing this one. So this is also known as the hybrid approach. Going ahead. Now I'm just trying to show you the one of the animated version, how things are working. Later you can run this animation again and again and you can see to understand. I hope that you understand the things very clearly. I try to brief all of the things in a more simple way as you can understand. If you don't, you can ask at any time. No problem. Okay, and feel free to ask, and I will appreciate your questions. So now you see the encryption. This is Alice, and this is the padlock boxes. So now what he's trying to do, the Alice seems very much beautiful, not to be worried. We are just concerned about the functionality at this stage. So see, one time I'm just running the whole animation for you, and then we'll come back and show you again. So this is Alice. Alice is saying hi. Hi is just going to be packed in the box. Then Alice padlock means he applied the key. And then what happened? Alice padlock key. Means the one of the key which is applied. Now what happened? Data is going to travel. So it is going to be transport. Means this is the data is going to be transport. Okay. Now when it reaches to the Bob, so what the Bob will do? The Bob will use his padlock key and the other key, which is actually from the Alice. So it means they are using the two keys. So now it will be open from this. You see the one key from him and one key from him. So this is a asymmetric approach. So now this is open, and now he will be happy to have the high band. So this animation is actually showing to you that how public key is operating. Just see here. Here Alice, he said hi. Now apply the one key which is a public, one key which is Alice, this is the private key. Then data is traveling, data reaches to the destination. Now Bob is ready to receive the data, but he need one is the public key which is being used by the Bob. So that's why this is saying the Bob padlock. And then he is using his own private key, and then he is able to see the message hi. This is the public key model. The key is broken into a public and a private part. Bob and Alice publish their public key for all. Public key is commonly available for everyone. So this is the same thing, the same operation. That's what we just have in the animation. So he's just trying to explain you here. This is Alice saying hello, Bob's public key, and this is here reaching the message and again using the key. So I hope you understand. And the next class we will discuss about further about the symmetric key, and we'll see that how that is working. And now you will know that how is the symmetric is different from the asymmetric. So this is just only for you. I just got impressed from this one. So always using this one. The best teachers are those who show you where to look, but don't tell you what to see. So where to look means you need to understand the things, understand the concepts, fix the mixing blocks from the chain. That's what I'm always saying. Means I will not tell you what to see, but not only that this is symmetric, this is asymmetric, and see, and that's it at class. No. You're very good students. I realize from one or two of your presentations. So I hope that you understand this one. Now we are done with this, and then we are going for your attendance. Meanwhile, if suppose you have any question, please ask the question. You are most welcome at any time. Before that, please allow me to stop the recording and also to stop sharing for this, as I can share the screen for attendance with you.